According to Article 250, a portable generator is considered a separately derived system. This means the neutral bar within the generator must be bonded to its frame, and the frame must be bonded to the grounding system. When testing continuity, it's normal to find continuity between the neutral bar, the frame, and the ground bar. However, there should be no continuity between the hot bus and the neutral bus. If the hot bus were inadvertently bonded to the frame, any appliance connected to the generator would be energized through its frame, creating a significant shock hazard. To mitigate this risk, ground fault circuit interrupters, or GFCIs, are used to protect downstream receptacles. If current flows through the grounding conductor, as it would during a ground fault, the GFCI will trip, interrupting the circuit. The neutral to case bond within the generator will not cause objectionable current on the frame unless there is another neutral to ground bond elsewhere in the electrical system. The generator's neutral should only be bonded to the system ground at the generator itself. In the event of a ground fault, the overcurrent protective device, or OCT, should open and clear the fault, effectively removing any hazardous touch voltage. To enhance safety, all portable generators should be connected to the structure's grounding system, typically through the use of a grounding rod. Understanding these principles is crucial for ensuring the safe operation of portable generators and protecting personnel from electrical hazards. The bonding of the neutral to the frame is a critical safety measure in separately derived systems such as portable generators. This bond ensures that in the event of a ground fault, a path of low impedance is available for the fault current to flow back to the source, allowing the OCT, such as a circuit breaker or fuse, to quickly trip and energize the circuit. Without this bond, the fault current might not be high enough to trip the OCT, potentially leaving the equipment frame energized and posing a shock hazard. The GFCI protection adds an additional layer of safety. It monitors the current balance between the hot and neutral conductors. If there is a difference of even a few milliamperes indicating that current is leaking to ground, the GFCI will trip, quickly interrupting the circuit and preventing a potentially dangerous shock. It is important to understand that the GFCI does not protect against overloads or short circuits, but specifically against ground faults. The grounding rod serves as a connection to the earth, providing a path for fault current to flow back to the source. This helps to stabilize the voltage in the electrical system and reduce the risk of electric shock. The grounding rod should be properly sized and installed according to local electrical codes. The absence of a secondary neutral to ground bond is vital to prevent circulating currents. If there were another neutral to ground bond downstream from the generator, it would create a parallel path for neutral current, leading to objectionable current flow on the grounding conductors and potentially interfering with the proper operation of the GFCI protection. This is why it is essential to ensure that the generator is the only point where the neutral is bonded to ground in the system. The overcurrent protective device, or OCT, is designed to protect the electrical system from overloads and short circuits. When a ground fault occurs, the OCT will trip if the fault current exceeds its rating. The OCT should be appropriately sized for the generator and the connected loads to ensure that it can effectively protect the system from overcurrent conditions. It is essential to regularly inspect and test the GFCI protection to ensure that it is functioning properly. This can be done using a GFCI tester, which simulates a ground fault and verifies that the GFCI trips within the specified time. If the GFCI fails to trip, it should be replaced immediately. In summary, the GFCI protection, neutral to case bond, proper grounding, and correctly sized OCT work together to provide a comprehensive safety system for portable generators. By understanding these principles and following proper safety procedures, you can minimize the risk of electrical hazards and ensure the safe operation of portable generators. Furthermore, it's crucial to emphasize the importance of adhering to the manufacturer's instructions and all applicable electrical codes when installing and operating portable generators. These codes are in place to protect individuals from electrical hazards and ensure that the electrical system is installed and maintained in a safe and reliable manner. Always consult with a qualified electrician if you have any questions or concerns about the electrical system or the proper use of a portable generator. Remember to consider the total load connected to the generator. Generators have a maximum power output rating, and exceeding it can damage the generator, or create a hazardous situation. It is essential to calculate the total power consumption of all appliances and devices connected to the generator and ensure that it does not exceed the generator's capacity. Pay attention to the starting wattage of certain appliances, which can be significantly higher than their running wattage. This is particularly important for appliances with motors, such as refrigerators, air conditioners, and power tools. The starting wattage can briefly exceed the generator's capacity, potentially causing it to overload and shut down. Consider using a generator with a higher capacity or staggering the start times of appliances to avoid overloading the generator. Before connecting any appliance or device to the generator, make sure that it is in good working condition and properly grounded. Damaged or ungrounded appliances can create a shock hazard. Inspect the power cords for any signs of damage, such as cuts, cracks, or frayed wires. Replace any damaged cords immediately. When connecting appliances to the generator, use heavy-duty extension cords that are rated for outdoor use. Avoid using lightweight extension cords, as they may not be able to handle the current load and can overheat, creating a fire hazard. Never operate a portable generator indoors or in an enclosed space. Generators produce carbon monoxide, a colorless and odorless gas that can be deadly. Ensure that the generator is located in a well-ventilated area, away from windows, doors, and vents that could allow carbon monoxide to enter the building. Install carbon monoxide detectors in the building to provide an early warning of carbon monoxide buildup. Regularly maintain the generator according to the manufacturer's instructions. This includes changing the oil, cleaning the air filter, and inspecting the spark plug. Proper maintenance will help to ensure that the generator operates efficiently and reliably. Store the generator in a safe and dry location when it is not in use. Drain the fuel tank before storing the generator for an extended period to prevent fuel from deteriorating and clogging the carburetor. It is also essential to have a qualified electrician inspect the generator periodically to ensure that it is in good working condition and that all safety features are functioning properly. This will help to identify any potential problems before they become serious hazards. Always use caution when handling fuel. Fuel is flammable and can be explosive under certain conditions. Store fuel in approved containers away from heat, sparks, and open flames. Do not smoke while handling fuel. When refueling the generator, turn it off and allow it to cool down completely before adding fuel. Wipe up any spills immediately. Consider using a fuel stabilizer to prevent fuel from deteriorating during storage. This can help to extend the shelf life of the fuel and prevent it from clogging the carburetor. Be aware of the noise level of the generator. Generators can be quite noisy, which can be disruptive to neighbors. Consider using a generator with a noise reduction feature or placing the generator in a location where it will not disturb others. Check local noise ordinances to ensure that you are not violating any regulations. When using a generator to power sensitive electronic equipment, such as computers and televisions, consider using a generator with an inverter. Inverter generators produce a cleaner and more stable power output than traditional generators, which can help to protect sensitive electronic equipment from damage. Be prepared for power outages. Have a plan in place for how you will use the generator to power essential appliances and devices. Make sure that you have enough fuel on hand to operate the generator for an extended period. Keep a flashlight, batteries, and other emergency supplies readily available. In conclusion, using a portable generator safely requires a thorough understanding of electrical safety principles, adherence to manufacturer's instructions, and compliance with all applicable electrical codes. By following these guidelines, you can minimize the risk of electrical hazards and ensure the safe and reliable operation of portable generators.